Hi students, today we're going to look at 5 tutorial questions related to Chapter 5, Differentiation. Question number 1, tutorial 5.1. Determine where, if anywhere, this function means that if we can draw into a graph, we can see a certain curve. This function is not changing. Or the definition of not changing is gradient is 0. So we have the given function q here. If we use a website or we do it manually by plotting a function against x against the function, we can get a sketch of the graph. Let's say we use a website to draw it. We might get something like just roughly something like, we're not sure, something like this. So what we want to find now is what is the coordinate, or what are the coordinates, or what are the x when gradient is 0. Gradient is 0 means that there's no changing in terms of the trend. It happens here, 1 point, and second point here. This is defined as gradient equals to 0, m equals to 0, or dq respected to x equals to the 0. Means that for this problem, we need to find what is the derivative of the q function. We are given q, x is defined as this expression here. Our next task is to convert the function into a derivatives. Because we have the exponential and we have the sum, also we have the different connection between the terms here, means that we're going to use all this combination. We are differentiate dq respected to the x here. So we will have 3x squared plus 18x minus 48. This is the derivative of the q function. To find when the coordinate is not changing, dq respected to x equals to 0. Now we have a quadratic equations. We can use the calculator or we can use the factorized approach to solve it. So we get x plus 8, x minus 2. 0 is x plus 8, 0 is x minus 2. X, after we adjust, we get x equals to 8, x equals to 2. Means that this graph, this curve, when x equals to negative 8, it has a stagnant, or the gradient equals to 0. When x equals to 2, it also has the gradient of 0. So we have solved for tutorial 5.1. Next question, tutorial 5.2. We want to find the dimension of a rectangle farm with area of 100 meters square. Our mission is to get the smallest length of our perimeter. Okay, we have a farm. It is 100 meters square. A farmer wants to build a fence covering this area, and he wants to spend the less money possible to buy the fence. Means that we want to have the smallest perimeter of the fence. For this problem, we don't know what is the width and we don't know what is the length of the farm here. Means that we need to write as an unknown, W and L here. Area is equals to the width times the length. We know area is 100, so we're going to erase area, so we're going to replace with 100. In order to proceed further later on, so we are going to subjectize one of the property. Let's say we use the width equals to length, 100 divided by the length. We have the first relationship between the width and the length. This is all about the area. Now we look from the how to say, the perimeter, the pagar, the fence perspective here. Oops. Okay, perimeter. is made out of the width plus the length plus the width plus the length. Now we have width and length in this first equation relationship. Means that we can erase the width, the length, and replace with width minus, is equals to, oh, my mistake. Wait. We have the width as the subject, means that we can erase the width and replace with 100 over the length. Erase it, replace it 100 over the length here. I want to build the fence, the perimeter for this farm. And it made out of 4 sides. The first side is 100 divided by the length plus the length plus 100 divided by the length plus the length. After we simplify it, so we will have 200 divided by length plus 2 length, the perimeter. Our intention is to get the smallest perimeter as possible. It means that we want to find what is the minimum length that can produce the minimum perimeter. So we will differentiate the perimeter respected to the length. So what we will get is minus 1, 200 plus 2. To find the minimum or the maximum, so we will say that the derivative of the function perimeter respected to the length equals to 0. So we'll move to here. 0 equals to minus 200. So L squared equals to 200 minus 2. So the length square equals to 100. The length at the end, after we set it, we get 10 meter. So the length is 10 meter. We can erase the length and replace with 10 meter. How about the width? The width defined as 100 divided by the length. So the length is 10. 100 divided by 10 will be 10 meter. So this will be 10 meter too. Means at the end, in order to get the minimum fence size, that is the minimum perimeter, we would suggest that the width should be 10 meter and the length should be 10 meter. So when the farmer used the derivative and finding the gradient equals to 0, that is to get either the minimum or the maximum. So we get the length and the width is 10 meter and 10 meter. Means that if he use the width 10 meter and length 10 meter, he's going to save a lot of money. At the same time, he's going to maintain the area is 100 meters square. Let's go to tutorial 5.3, third question. Okay, we read the questions. There is one open rectangular container and the base is square. And then the total area of this container is 48 feet square. The container is used as the water storage. And now we want to find what will be the dimension. The dimension means that we want to find the height, the width, the length of this container, rectangular container. The criteria is we want the container have the largest possible volume. Means that we want to find the derivative of the related functions equals to 0. When equals to 0, it indicates that it might be maximum or the minimum situation. Okay, let's draw the container first. We have open container. The base is square. Since the base is square, at the same time, we don't know what is the size. We don't know is it 2 meters or 2 feet or 3 feet. So we just say that, okay, we'll use X to represent it. We don't know what is the height. So we may use the y to represent the height. It says that the total area size of this open, it has no cover, is 48 feet square. So we use 48 to simplify the situation. When we break down this rectangular container, it is made up of 1 square plus 1 side here, 2 side, 3 side, and 4 side. Okay, this square, it has the dimension of x and x, and this dimension has x and y. So we have x squared plus 4 set of the xy, and this is the total area of the rectangular container. Is equals to 48. We will make some adjustments so that we will have the subject to represent the equation. So 48 goes to x plus 4y. 48 divided by the x goes to x plus 4y. Then we'll move 4y to the left side. 48 minus x. So later on we will have y equals to divide. We have 12 over x minus x over 4. So we have the relationship between the length and also the base, the width and the the y is the height. So we shall continue. We erase a little bit. We maintain the important information about the relationship between x and the y. Okay, our mission is to find what is the maximum volume can be created. To find the maximum volume, we need to find the relationship between the volume x and y. So volume equals to the length times the width times the height, right? X squared times the y. You want to make the things not so complicated by reducing what the numbers of the unknowns inside. So since we have y is also have another name related to the x, so we'll say that y, I will change your name. So we have 12 so later on we'll get 12x minus x power 3 over 4. So the next step is we want to find what would be the maximum or minimum of the volume. So we're going to differentiate volume respective to the x here. So we have 12 minus 3x power of 2 divided by the 4. Okay, in order to make it minimum or the maximum, the derivative of the function need to be 0. So we'll go to the steps here. 0 equals to 12 minus 3x squared divided by the 4. So 3x squared divided by 4 equals to 12. 3x squared equals to 48. X squared is 16. So x will be plus minus 4 because we cannot have the negative. So we'll take x equals to 4 feet. Okay. When x equals to 4 feet here, we know that the square base is 4 feet and 4 feet. Now we want to change the height of this container into a number. What we know is y is related by the equation here. We want to find the height. We know that x equals to 4. This will be 3 minus 1. Okay, 3 minus 1 will be 2. Means that the farmer, he needs to modify the container with the size of the base as width is 4, the length is 4, and the height is 2, so that he's going to get the area is still 48. At the same time, the volume will be the largest possible. Okay, this will be the answer for tutorial 5.3. Tutorial 5.4. We will have one area of ink blot at time in second is a cm square, where the area and the time relationship is defined as area equals to 5t square plus t. Our mission is to find rate of change in blot area when t equals to 2 seconds. We are given the relationship, that is the function is 5t squared plus the t here. When we read the question, it asks us to find rate of change in blot area. That is to find the dA respected to the time. Rate of change means that our denominator should be the time element. When we look at the given function, we already provided with the function with the time, so we can direct use this function to differentiate, and we will get 10t plus 1. We want to find what will be the rate of change in blot area. We want to find what is this when our t is equals to 2 seconds. Okay, we can write in the standard format. We want to find what will be the rate of change in the blot area given that when t equals to 2, 10, t now we change to 2. Okay, this will be the answer for our case. The last question, tutorial 5.5. In a crop field, the nutrient absorption efficiency varies with the time. It changes over time. It's not absorbed constantly. It's not saying that, at the first hour, it absorbs, let's say, 50 gram. The second hour, it also absorbs 50 gram. No, it changed because of the weather. It changed because of the wind, because of the heat, because of many factors. However, we know that there is a pattern showing the absorption over the time. This is the pattern. This is the formula. Y equals to the cos 1 plus x power of 3. We want to find how the nutrient absorption efficiency changes as the time passes. So now we want to find what would be the nutrient absorption when the time passes. It's similar to the rate of change, only that for this case, it doesn't specify that the time use the t to represent, it used the x to represent. So this is what we want to obtain, dy respected to the dx. We are given the initial function. For this case, it seems like a function inside a function, we can use the chain rule. In order to use the chain rule, we give a name to represent one of the function, 1 plus x power of 3. Let's say we use u to represent 1 plus x power of 3. When we differentiate the function u respected to the x, we will get 3x squared. Go back to our mission. We want to find what would be the differentiation, the function y respected to the x. Since we have the chain rule applied to this problem, so we can write it as dy over respected to du times du respected to the dx. When we look at the general formula to find what would be the dy respected to the x, we have solved for the du respected to the x. This one we have it. It is 3x power of 2. What we don't have is dy respected to the x. Okay. To find this, is related to the u and the y. Okay. The y initially is cos 1 plus x power of 3. Yeah. Since we have another name to replace 1 plus x power of 3, it's called the u. So we will have u here. When we differentiate dy respected to the u is minus sine u. Means that we have solved for the dy here, respected to du. It is negative sine u. But we don't, from the beginning, we never have the u. We only have the y and the x. Means that we need to replace u with the 1 plus x power 3. So at the end, we will get the final answer is dy respected to dx is negative sine 1 plus x power of 3 times 3x power of the 2. So arrange it nicely. We'll have negative 3x power of 2 sine 1 plus x power of 3. This is the answer. Okay, that's all for the session today. So later on, you will choose one of the questions, modify yourself, and create a YouTube video for your tutorial session.